Hey, this is Bill Mallon. We're back again with another edition of The Helm, and today we're with Sean Rodell in Panama City, Florida.
Bill, welcome to Florida.
And what facility are we in here, Sean?
This is our Oceaneering umbilical facility in Panama City where we make umbilicals worldwide.
Umbilicals, and so we hear a lot about umbilicals at Oceaneering. I'm going to ask you more about that, but let's talk about the size of this place first. I mean, it's quite a walk to go down the hall. How far do you think that is?
So it's almost a quarter-mile long by the time you go from end at the very bottom of the stairs all the way to the other end.
And why in the world do we need a building that's this big?
When you're making big, long, complex umbilicals like we do, a lot of steel tube components, they don't bend well. And so you really need a lot of smooth spaces for them to be able to go in long areas to be able to run them.
I mean, I'm looking forward to going outside and showing it. I mean, if you've not been to this facility, it's amazing what goes on here. So I'm looking forward to that. But before we get into that, tell me, what exactly is an umbilical?
So an umbilical is the way that an operator can deliver chemicals to the well. They can deliver power to control pumps or the Christmas tree or anything else that's on the seafloor. They can also deliver signal back and forth between the areas, and then pump hydraulic fluid to whether it's to open and close a valve or to perform other functions.
So Sean, this is, I guess, a cross-section of an umbilical, if you will. So basically it's been peeled back, and from this picture, I mean, this is obviously some big reel. How big is this thing?
So this is about 30 feet tall.
And then this is the umbilical.
Correct.
Which is basically a tubing system. And so we're looking at, if we were to cut this in half, basically, that's what we're looking at here.
Exactly, although this is much smaller than the one right here. This is a really big one that we didn't do on a reel.
Okay, and so if I look in here, so I've got, I mean, all these cables, various cables, lots of different, that looks like, is that a fiber optic cable down there?
Yes.
And is that a fiber optic cable?
Yes.
And look,
Bill, you're getting really smart
yeah,
at this.
you know, I've been out in the shop for quite a while, and they've taught me quite a bit. And then I've got a bunch of steel tubes in here as well with some more electric cables on the back.
Correct.
So is fluid pumped down those, and how does that
Correct.
work?
Yeah, so if we look at the steel tubes right here, so the vast majority of these will either pump chemicals to the well, or they'll pump hydraulic fluid to be able to open and close different functions that are on the floor.
And these are some significant cables to power something down there.
Yeah, these are some of the biggest cables that we've done here in Panama City. This was a job for Shell. It was a BC-10, and these will power pumps that sit on the ocean floor. And then some of these other smaller electricals that go through will actually transmit electrical to actually, you know, whether it's to turn a valve or something else that's smaller.
So the guys in the back taught me that this isn't just like one pass through this massive machine we'll show in a minute. You have to do this part, and then that part, and this part, and then put all these parts together, and then run all those parts through this machine. I mean, this isn't an insignificant, I mean, this is a pretty massive thing.
This is one of our trophy projects we've done in Panama City.
And
one
this
of the
is
bigger
for whom?
jobs. So it was done for Shell in Brazil. It was BC-10. And it had to go through the facility multiple times, Bill, you're right, to put the triads together, and then the first pass, and you can see we ran it through an extrusion, and then we had to put all the rest of the tubes around it again, and then another extrusion. So this was a lot of work.
And so how long was this when all was said and done?
So this umbilical was likely 5 or 6 miles long.
5 or 6 miles long.
Yes.
And you make it all here. Wrap
Yes.
it all here, and it goes, I mean, it goes in one side of the building, comes through the ceiling almost, and goes out the other side, which we'll show in a little bit, and it goes out on these big reels. How much does a reel like this weigh?
Well, so this reel right here, so the smaller umbilicals will actually go on a reel like this. So this will end up weighing about 300 metric tons that goes out. So if it's a small one, so if it's only a couple of miles, it will go on a reel like this.
Right.
Some of the other jobs we've done right here are 50 or 60 miles long. And so those can't go on a reel, so they have to go on a larger carousel vessel.
So you make a cable with all this stuff, or let's walk over here, Mike. You want to follow us real quick? This one's a lot different in that it's got a big tube in the middle, lots of tubes, and a whole lot less electrical in it. So, well, before we talk about like how long it is, tell me about this one. Why is this one so different?
Yeah, so this is vastly different. So the one we saw before was in Brazil, and it was to power the pumps. This was for Angola, so it was done for ExxonMobil. And the point, and this big tube down the center was meant to pump MEG to the floor to actually for well control, and make sure that was done so they could have good flow control. So the big one, and it's big, it's a thick, viscous fluid that goes through, which is why it needed to be so big. And then the other similar ones you see where, again, other chemicals can be injected or hydraulic fluid, and then you see
a little bit of electric power.
Yes.
Yeah, and then there's one more over here. Mike, can we walk over here real quick? You can see behind the scenes of the helm. Now this one's completely different. This one's a whole bunch of tubes inside of there. Tell me about this one.
So this one's done for shell apomatics. So this is Gulf of Mexico. So you look at the 3 ones we've looked at. So we've looked at Brazil, we've looked at Angola, and now we're looking at Gulf of Mexico. And part of it is the characteristics of the wells that you see in each of those areas and what we need to do. So a lot more in terms of chemicals that are done and the hydraulics that are in place. So a lot of the smaller tubes that you see in the Gulf of Mexico size with some big thick ones on the outside that we're taking care of.
So are any of these the same?
Every single job we do is different, and so it has to be designed at the very beginning with all the characteristics of the well that's going to be done, of the flow, whether it's a floating unit, how long it's going to be, the tiebacks, the chemicals that go in. So a lot of engineering has to go in place.
I mean, a lot of engineering.
Yes.
I mean, they were talking about, when we go outside, they were talking about how they have to, like the weight on the machine. We'll talk about that in a bit. All right, Sean, so what I have here is the, remember those little...
I thought that's triple.
Yeah, well, that's, yeah. So this is the, when we go outside...
So I didn't realize you're a real Star Trek fan,
That's it.
Bill.
To stop the wind, like the little trolls, remember those?
Oh.
To stop the wind noise.
I'd rather it be a triple.
So this is the, what's the quarter-mile hallway that we're walking down, and I noticed I'd like to stop here at one of these windows. There's a couple of them, and as I look out this window, I've got, this is a big reel, is that correct?
Big carousel.
And what's inside of this big carousel?
So this is an umbilical that's in process. So it's covered because all the UV light that comes in here in Florida, you need to have proper protection for it.
So the protection would be the coating that you put on. So basically this is the inside of one that needs to be covered.
Correct.
And if we walk down here to this next, well, actually it's a long walk to the next window here, but. All right, so then as we walk up here, I've got an umbilical out here, is this right?
Yes.
And is it 2 umbilicals or 1, or like, because there's two rows?
Yeah, exactly. So these are actually 2 separate umbilicals that are in place, and you could actually put multiples on it when you stack them on top of each other, and each of the carousels can actually operate independently, so you could actually have one going in one direction and another going on that if we're doing it separately. But these are 2 separate ones that we have, and if you look just at the size of it, so you've got about 50 meters in diameter.
I mean, look at
carousels
this thing.
that are out here.
There's a massive forklift out there. There's a welding station. There's a light cart. There's a welder, and they're insignificant in the size of this thing. Let's continue, because I would like to take us outside. We still have about, I'd say, more than 1/8 of a mile to walk here, but I'd like to go outside and look at some of these reels. So I'm going to slow us down again right here, because there's something else out this window I would like to talk about before we go look at these reels. What am I looking at here?
So what we're looking at here is the Scott Bay carousel. And so for years, we worked for just those other carousels, and Scott Bay kept saying, we need another carousel, we need another carousel. And I told Scott, if you sell enough product to need another carousel, we'll build it.
And so it's turning right now. So what's happening here?
So when we go down, we'll be able to see it's actually processing this center pass. It'll go through the cabler, so it'll go from this carousel all the way over, and it's going to be processed.
And so is this the job that's going on inside right now?
Yes, it is. So this is Anadarko Constellation.
So it goes in the building and then out of the building and ends up on one of these big, massive reels.
Yeah, since these are all so big, and the product is, they actually start on the outside on the carousel, they go through the inside to be processed, go through, they're processed, and then they go back out again onto one of the other carousels.
Well, let's go look at a reel, and then we'll go inside and look at that.
Okay.
All right, perfect. Sean, come over here. You're a little bit taller than I am. I mean, and Mike, if you could back up just to show the sheer enormity of this thing. I mean, I don't know if you've got the entire thing in frame or not, Mike, but this is, how tall is it again?
11.4 meters.
I mean, just unbelievable. And do you know how much cables, how much umbilicals on this
So
one?
it could hold up to about 400 tons. So this is probably going to be about 8 or 9 kilometers.
And why
potentially be on this?
Oh, I guess, why, okay, so why 2 sides? Why not just roll it all up in one continuous?
So this side that has UTA, this will be on the ocean floor.
Uh-huh.
It goes in place, and this will plug in up to the top side.
Now, over here we have this little bitty crane. This thing is used to pick up these reels.
Correct.
And it's on this big, I don't know, like a base with multiple arms on it, and it can pick up these reels no problem and load them to the vessels.
Yep, so this can load generally up to between 300 and 400 tons. So if it stretches out really far, of course its ability to lift goes down, but close to the vessel can lift up to about 300 tons or more to move onto the vessel.
Unbelievable. Now, I'd like to go back inside to show, Mike, can you show how that umbilical is up there? And so Sean, it's going in right now on this side, right?
Yes.
All right, I don't know how to get in there to follow this in, but
Yep.
can we follow this in?
Yeah, we can.
So this is what we were showing out there. This is where the cable comes in from the outside and it's going this way. This is the center part, is that right?
Yes. Yes. So this is a multi-pass umbilical. So this is the center part that goes through the center, and then we'll wrap everything on the outside of it as it goes through the cable.
Okay, so there are components, either tubing or electrical wires inside of here,
Yes.
and then this will go, and you'll put more tubes on the outside of this, and
Correct.
more wires or whatever.
So this has already gone through once already, and so this is actually taking it through
So
the
it's
cable
coming
the
off
second
that reel,
time.
and then it goes through this. Now here's where we get to the good stuff.
Right.
So let's walk over here and look at this a little bit more closely, because I want to make sure I understand this thing. So Mike, if you could show, that's that inner part that's coming in from the outside, and it's going into this machine. Now, when we go through here, is there electric? There's purple wire, I guess, and there's red wire.
So those.
Can we safely go here?
Yes. So, we can go there. So all the colored components are all the electricals that are going through. And then you can see all the steel tube that's going to be a little bit further ahead that's going to be winding around from each of these bays.
And so,
So
actually,
you can even see right here the
Yeah.
size of these reels that are inside these cradles.
and then all of this goes up there, but it's wrapped with some other stuff. Can we go up here?
Yep, we can.
Sean? And so all of that comes together right here, and it's twisted up into, into this.
So it goes through that closing die, so everything has to fit in precisely. I mean, that's an engineering feat in and of itself, and fit into that closing die, and then you look what a nice package that is right there to be able to come through that end of that closing die.
But then also, like this smaller yellow cable that's coming in, are there cables inside of it as well, or is it just a solid cable?
No, so that actually has 4 smaller electrical cables inside it.
So that
we're
has
going
to
through.
be made prior to putting it in here.
Exactly. So since we make almost every single thing that goes in umbilicals, we'll make the electricals, we'll make the fillers over on the other side of the building.
Can we go look at that?
Yep, we can certainly do that.
All right, so we're going this way, but yesterday we were back that way. So tell me what's going, why did we transfer from one to the other?
So we've got to logistically plan to figure out which components need to be made when they go into the different product. And so this one went today, it goes into this product that goes the next day, that then goes right after that. And so the operators have to be able to run all sorts of different machines to be able to put this in place.
I mean, and I keep saying this, it's just like engineering logistically, this is not a simple thing.
Right. The logistics, the schedulers we have on the shop floor to be able to work out and figure out the order of operations that we're going to do them when, with the manpower we have, to make sure it's done and ready in time really does make a difference.
And if one little thing goes wrong, if you guys haven't planned, it's not pretty.
Since a lot of these operations, even some of the things we buy, take weeks and weeks to come in, it stops the whole operation. So it's got to be flawless execution.
So I've heard that, and I don't know if a gentleman was bragging, and maybe you're going to brag too, but I've heard this is the honest to goodness truth, and that customers come to us because we are known for delivering on time. Is that an accurate statement?
Bill, at this facility for the last 8 years, we've delivered on time 100% of the time.
How many of our competitors do that?
0. It's not even close.
All right, let's go over here and look at this. I'm Bill, this is Mike on the camera. Can you tell us what you're doing right here? Well, tell us who you are first. You're Tony?
I'm Tony Brown.
And Tony, what do you do for us?
I'm running the single twist over here. I'm a senior operator.
What's single twist mean?
Single twist, we twist cables. Some of them are for communication cables. Some of them are just for power cables.
And these are the components that go inside of another component, which ultimately ends up inside the umbilical.
Absolutely.
So what are you doing right here? It looks like you're starting something on the spools like we talked about earlier. Everything's
Yes.
on a spool. So what are you doing here?
Right now, we're setting this particular project up for testing. We want to put a pigtail in there for at
What's
the
a
end.
pigtail?
Pigtail is at the end of the run. The testing department comes in and tests the product and make sure from start to finish that there was no blemishes or any problems in the process.
Okay, so that's what you're putting a pigtail on it now.
Yes, sir.
And then what will happen? You will do. So this is the pigtail, or
Pigtail is going to go through there and wind around about 30 feet of it, and we'll secure it to the inside of the reel, and then the rest of the product will go onto the reel itself, and then we'll start the machine up, and it'll start the process of laying it onto the
Are you going to start
reel.
the machine anytime soon?
Yes.
Can we come back and see it?
Yes.
All right, perfect. We'll be back in a little bit.
Okay.
All right, Tony,
Good.
thanks. How are you, sir?
Good.
What's
How are
your
you?
name?
Josh Kramer.
Josh, is everybody in this facility as big as you? Because I couldn't find a small shirt anywhere.
No, sir.
And I think I'm figuring out why.
Yeah, but well, most of the guys up here are pretty big. So,
Well, Josh, what do you do for us here?
I'm a work center tech. This month will be my 11th year here.
11th year.
Yes,
and so
sir.
what does that mean, a work center tech?
Work center tech is just a fancy word for a lead.
So you run this machine?
Yes, sir.
Basically.
Yes,
And,
sir. I've been up here for 7 years.
and Josh, I noticed, so it makes a lot of noise, lots of different moans and creaks and all of that. I mean, is it like a car? You kind of know what's going on? Or?
Well, as the machine runs, you're looking for sights and sounds, the components, how the components are acting, how the components are, how the sound's coming. If you listen to the machine will tell you what's going on. If you hear new noises, new sights, the components are acting different. The machine's telling you that something's wrong.
And does each umbilical make different sound? Like you make different ones? They all have their different
Yes, sir.
sounds?
Each umbilical has different tubes, different components, different size conductors. Everything acts different. You have different tensions. It's on the size of the tube, the size of the conductor.
It's just so impressive.
Yes, sir.
All right, well, I'm going to let you work. I'm going to get out of your hair. So
Yes, sir.
Thanks
No problem.
again. All right, Josh, take care. Josh, I just found out from Sean that the Safe Life, that's your design.
Yes, sir.
And so what exactly, because I noticed that's on the back of some of the shirts that employees wear.
Yes,
Tell me
sir.
what that is.
It's a turtle because we're by the water, and I just use the umbilical cross section
Yeah.
as a shell, kind of to symbolize us being in Panama City and an umbilical.
And who told you to do that?
Nobody.
You just Safe Life, I mean, that's just the culture here.
Yes, sir. It is.
That's great. Josh, thanks
All
again,
right,
buddy. Take care. Okay, so now we're here with Stan. Stan, what do you do for us?
Testing technician.
And what does that mean?
I work in the testing department, and we get the umbilical and flying leads. Once they're built inside, they come out to us, and we're going to assist along with the welders, make sure the ends get put on, take it through the process, electrical and hydraulic testing.
So is this part of the testing equipment back here? What am I looking at?
This is a flushing unit. We'll fill with this. This is a Shell Appomattox project right here, and we'll fill the line, and then we'll flush it. We'll do 3 cycles with it, make sure the fluid's clean. Then we're going to send it out. With a lot of times, it's the actual fluid that's going to be used in the field for their hydraulic fluid that they're going to use. So we got to make sure it's clean.
To make sure everything's clean when it goes out.
Right.
Now,
exactly.
I heard that you're always this clean right now. Is that right? Brand new shirt and all that. Is that accurate?
No.
No, you're
that's
not
not
usually.
accurate.
So
No.
you put the shirt on for us?
That's right.
That's awesome.
That's right.
Well,
And then I'm going to go get on my work clothes.
All right. Well, thanks a
soon
lot
as
for
we're
taking
done.
the time to talk to us,
Thank
Stan.
you, sir.
All right. Bye.
Bye.
So, Tony, I told you to come back, and you've got the machine running now. So tell me what this machine is.
The single twist is twisting right now a quad.
A quad. What does that mean? 4 wires?
4 conductors,
conductors.
with a filler going down the center.
So this operation, I mean, obviously to me it looks extremely dangerous. I'm sure you guys practice some serious safety here.
Yes, we do.
And it's like, I mean, obviously I can't go in there. Is that controlled somewhere?
Yes, it's controlled at the HMI screen. It's anti-locks that anytime that one of the circuits have broken, it will automatically shut the machine down.
So if we walk in there, it would just shut down
It would
the
shut
machine
the
for
machine
safety
down.
reasons. And I can clearly see why. So walk me down through this. As we come down through here, tell me what's happening. So the cables come through.
The cables are paying off under tension,
Uh-huh.
and they're being twisted coming up through
Okay.
the die.
So they drop down and then they come through here.
They come through configuration up here that also follows the same coordinates as the bays that it's in right here.
Uh-huh.
We got a number system.
Can we go up?
Yes.
I took the safety thing, so can
Yes.
we go up here?
Yes, sir.
Okay, let me go here. Now this was a very interesting looking thing, and Mike, if you could shine inside of there, and Tony, tell me what we're looking at here.
We're looking at the capstan. What this machine does, it holds the tension as it's being twisted, and it goes through the take-up stand.
And the take-up stand is where? Right over here?
Yes, the take-up stand goes through here, and the machine actually takes up the product that we've just twisted onto the reel, and through different coordinates that we put on the different flanges, it level winds it for us.
So I've mentioned this to Sean several times. It seems like you guys, it's this reel to that reel and this reel to that reel. I mean, a lot of switching back and forth.
Yes.
And can we walk down here? Real
Absolutely.
quick? Let me turn off. Mike, turn off the camera so that we're safe going down here.
Okay.
So this is
This
generating.
is the take-up.
And I mean, this is a lot of momentum
Yes,
spinning
it is.
around here, and so all of that is it comes through here and it's being wrapped on this spool,
Absolutely.
and then this spool will then go down the line. It'll get the yellow stuff, as I've been calling it all day, or the red stuff over the top of it, and ultimately end up in the final umbilical.
Absolutely.
All right, Tony. So I'm looking at this, and I have to ask a question. You said you're not Florida State. Who are you?
University of Miami.
And so, are there any University of Miami colors in there?
Yeah, we got green in there.
But you need some orange.
I
in
need
there,
some
right?
orange in there.
I'll talk to Sean and see what we can do
There
there.
you go.
All right, Tony. Thanks you very much.
All right, brother.
take care.
Appreciate you.
Yeah, bye. So we've walked around this place quite a bit, and I mean, again, unbelievable stuff. So I think let's go back into the air conditioning, and I got a few more questions for you, and we'll shut her down from there.
Bill, that sounds much nicer.
All right. Yeah, all right. Okay, so Sean, so you're talking about, I mean, we looked at 3 here, and they're all different. You're looking at something that can be up to 40 miles long. How deep can these things go?
So the deepest one we've done is 3,000 meters, and that was done for shelf stones in the Gulf of Mexico.
So let me do some math here. 3,000 meters, about 10,000 feet, or like 1.8 miles
Yep,
underwater.
that's correct.
And the pressure doesn't crush the tubes in there or anything?
Well, and that's a lot of the design that we need to take a look at, is what are the pressures going to be, what are the temperatures going to be coming from the well, from the depth of the water, and a lot of that design that goes into the engineering for that cross-section takes a look at things like water depth and temperature and pressures and other things. That
I mean, 1.8 miles underwater, going from subsea floor up to a floating product. I mean, it's pretty amazing.
In fact, you got to talk to one of the analysts that do a lot of the work in the engineering front, just to show the amount of engineering that needs to take place up front to get these things designed.
So now we're with Mimi. Mimi, Sean said that I have to talk to you, and Tom agreed. They said you're probably the most important person here. So tell us who you are, what you do for us.
I do the analysis. I'm in charge of analysis and calculations for the umbilicals, and we work on all the design, looking at the background calculations, making sure we size everything correctly and we perform the analysis correctly. So I work on the analyzing the cross sections from the basic design up to when it's installed in the water column.
So this is the cross section here that we saw earlier. And Mike, can you get this on the screen real quick? So this is a cross section. That's the tubing, the electrical, fiber optics, I assume, and then fillers. So tell me what you do. Like there's red things on there. What are those?
Those are called the crush pads. So during installation, you have a tensioner system, and the umbilical goes through it to be safely installed. And the reason why they go through a tensioner system is to hold the tension so that they can lay the umbilical correctly.
And to do that, it has to squeeze some, right?
Squeeze it. So this is looking at the maximum crush load that the design can take, so that we don't damage any of the components, and we are able to quantify what is the load that the umbilical can take for the installer.
I mean, because if you don't have that calculation, I guess you could crush this tubing or pinch these electrical, or maybe even mess up the fiber optics.
That's
So you
correct.
make sure that doesn't happen.
Correct.
Okay.
And we also validate it through testing. So we do the analysis to get the envelope, the safe operating envelope, so that we don't damage any of those vital components. This is very important to the client. This is the basis. If we don't get this one right, we're not able to continue with the project. So this is what we have to do to do the dynamic analysis, which is very important for a dynamic umbilical, and understanding what the configuration should be to avoid clashing with the risers, and to be able to withstand all the loading during the period that it has to survive.
You have a tough job.
Yes, I do.
Yeah, you do. All right. Well, I cannot guarantee you that I won't be back here, just in case Sean or Tom or anyone else tells me I missed something else. But
Okay.
once again, I very much appreciate your time.
You're
And I'll
welcome.
try not to
Thank
bug
you.
you anymore.
No
All right,
problem.
Mimi. Thank you so much.
Thank you very
Okay.
much.
So Sean, with the shop running 2 shifts, 24 hours a day, and I know you, safety is a huge concern here. And I had all my PPE when I was out there. Talk to me about your safety record here.
No, that's a great question. Of all the great things that we've done in the facility, the thing that I'm most proud of is the safety record. And if you look at just the chairman's awards that we've won, and keeping people safe, looking for engineered improvements and winning innovation awards. The fact that every single person in the facility is looking out for themselves, looking out for others, and making sure we're doing the best we can from a safety front. We're almost near 1,000 days right now with our last recordable injury, and so we've really made a focus to make sure that people stay safe here at this facility.
And the HSE guys that was taking us around did a fantastic job as well. I forgot his name.
Dave DeRuyter?
Yeah, he did a great job making sure that every time we were walking around, he'd watch out for this, watch out for that, because we're behind the camera sometimes, and so they just a fantastic job, and everybody out there is really safe as well, looking out for each other. So congrats on that. I mean, very impressive. All right, Sean. So before we walk out, I just want to say thank you very much for taking the time to show us around. I mean, it's a lot that goes on here. Very impressive facility, one that I'm sure you're very proud of.
Proud of the people here. You got a chance to see some of them today, the work we do, and we're excited to have visitors, even you, to come see us, Bill.
Well, I appreciate that, Sean. All right, thanks a lot. All right.